Welcome to this explainer. Ever stared at your website's analytics dashboard and just wished you could, fast forward to next month? Well, today we're going to learn how to do the next best thing. We're taking historical web usage data and transforming it into a practical, predictive crystal ball for your business decisions. By the end of this, you won't just be looking at what happened in the past, you'll be actively forecasting what's going to happen in the future.
All right, here's our roadmap for today. 1. Decoding web traffic patterns. 2. Anatomy of time series. 3. Finding signal and noise. 4. Building the ARIMA forecast. And 5. Data-driven business decisions. It's a logical, step-by-step journey from raw data to real-world power. Let's get into it.
Section 1. Decoding web traffic patterns. Okay, let's dive right into this by anchoring ourselves in a highly relatable, everyday business problem.
So, why did our traffic spike yesterday? It's literally the most common and usually the most urgent question every digital marketer or business owner asks when they sit down with that morning coffee and open up their analytics. You look at the numbers and boom, massive spike. Or, worse, a terrifying sudden drop. You immediately need to know why, right? Because understanding the why from yesterday is really the only way to replicate success or prevent a disaster tomorrow.
The thing is, web traffic is rarely just random. Time-based behavior is absolutely central to digital decision-making. Marketing campaigns create these very clear temporary spikes. Then you've got weekdays versus weekends showing totally different repeating volume patterns. Things like changes in search visibility, holidays, exams, or even technical hiccups, they all create these observable, unusual drops. Once we recognize that these shifts are actually driven by external factors over time, well, we stop guessing and we start analyzing.
Moving on to Section 2, Anatomy of Time Series. Now that we know traffic isn't random, we need to understand the underlying structural components of that web data. We really need to dissect it.
At its core, what we're talking about here is time series data. This is simply a sequence of observations recorded over time. The fundamental shift in our thinking here is crucial. Instead of asking a static question like, hey, what was our total visitor count last month? Time series analysis asks, how did visits change over time? And based on that exact sequence, what might happen next? We're moving from just accounting to actual forecasting.
And this brilliantly illustrates what we need to look for before we ever try to forecast. Every single web traffic time series can be broken down into 4 clear components. First up, the trend. That's your overall long-term increase or decrease in visits. Then, seasonality, the repeating predictable patterns, like maybe your traffic dips every Saturday. Third, the campaign effect, those temporary surges caused directly by your marketing. And finally, irregular variation. This is the random noise, the spikes or drops caused by totally unusual, unpredictable events. You absolutely have to find this structure first.
But, sometimes structure is really hard to see if you're standing too close. Changing your time granularity reveals the true power of aggregation. If you just look at hourly data, it's frantic, right? It's full of detailed short-term behavior. But as you zoom out and aggregate that data into daily, then weekly, and finally monthly views, you're actively reducing that short-term noise. It acts like a camera lens, bringing the broader long-term trends and repeating seasonality into sharp focus.
Section 3. Finding signal in noise. Of course, raw data is almost always messy. So before we can accurately predict the future, we gotta clean up the past.
Think of this concept, smoothing via a moving average, kind of like tuning an old radio dial. Raw traffic values move up and down violently day by day. That's the static. By applying a moving average, which averages out nearby observations, we effectively cut through that daily static. It smooths out the line, distinguishing the temporary campaign noise from the true general direction your traffic is actually heading. It really helps you see the actual signal.
But what happens when the signal just drops out completely? We have to do a quick so what check here on missing data. Let's say your server goes down for a weekend, or maybe a tracking tag breaks and you end up with blank spots in your dataset. If you leave those blank, your entire month-long forecast could just crash. By imputing missing values, like using a really simple forward fill where you carry the last known value forward, you preserve the usable data and ensure a smooth, mathematically sound analysis.
Now, what's really interesting about this is the concept of stationarity, which is really just a fancy word for stability. Notice the difference between a stationary pattern, where the average remains pretty stable over time, and a non-stationary pattern dominated by a really steep trend. Forecasting models are basically pattern recognizers, and they perform so much better when dealing with the stability of stationary patterns. If your data has a wild trend, we often have to stabilize it first before the model can even learn from it.
Section 4, Building the ARIMA Forecast. All right, we've cleaned our data, we understand its anatomy, now we finally introduce the mechanisms and tools used to predict the unpredictable.
You're going to hear the term ARIMA thrown around a lot in data science, but let's demystify it and keep it beginner-friendly. ARIMA stands for Autoregressive Integrated Moving Average. Please don't let the math scare you. All it really means is the model uses three things to guess the future. Autoregressive just means it looks at previous traffic values. Integrated means it handles those wild trends we just talked about to stabilize the data. And moving average means it looks at past forecast errors to correct itself. That's the whole shebang. Past values, trends, and past errors working together.
Let's move to the workflow and see how this builds out. You absolutely don't need to write heavy code or do complex math to make this happen. It's really just a logical sequence of steps. First, you load your file, then form the time series so the software knows it's date-based. Apply a moving transform to smooth the data. Build that ARIMA model we just defined. And finally, visualize your forecast.
To put that workflow into practice, we can look at a tool like Orange Data Mining. This visual programming sequence takes you directly from a raw data set on one end, straight through to a finished forecast with confidence intervals on the other. You literally just connect these visual widgets together. You define your dates, smooth the noise out, configure your ARIMA parameters, and feed it into a line chart. It's a real game changer because it completely democratizes the forecasting process.
And beyond just spitting out a prediction, tools like this provide incredibly powerful visual ways to inspect the data before you forecast. Things like correlograms and periodograms help you mathematically reveal repeating dependence and dominant cyclic frequencies. Basically, they confirm your suspicions, like proving definitively that your traffic spikes exactly every 7 days, ensuring the model you build is grounded in actual structural reality.
Section 5. Data-driven business decisions. Building the forecast is immensely satisfying, for sure, but it doesn't mean much if it just sits in a vacuum. We need to tie all this technical forecasting directly back to real-world business planning and outcomes.
First off, how do we know our new crystal ball is actually working? Well, we use evaluation metrics like RMSE, MAE, and MAPE. Again, keeping it simple, these just measure error. They calculate the difference between what your model predicted would happen and what actually happened in your historical data. The goal for all of these is simple: lower is better. A lower error rate means a tighter, much more accurate forecast that you can actually trust.
And trusting that forecast unlocks massive business value. Why? Because time series don't exist in isolation. They influence each other. Website visits naturally flow into page views, which flow into conversions. If our ARIMA model can confidently forecast an upcoming 20% spike in website visits, we can reasonably predict a subsequent increase in page views, and most importantly, a bump in actual sales conversions. It literally allows you to see the money coming before it even arrives.
This means every department wins. Turning these forecasts into action impacts the entire organization. The marketing team can plan future campaigns around projected organic dips. The content team can pinpoint upcoming high-performing weeks to drop their big articles. Sales can accurately estimate future conversions to manage inventory. And management gets a clear, mathematically backed monthly summary that completely removes the guesswork from resource allocation.
So, the absolute crucial point is this: models aren't perfect. Algorithms don't magically know that a global news event just happened or that a competitor just slashed all their prices. Forecasting models must absolutely be combined with human business awareness. You got to consider data limitations, quality issues, and weird outliers, and blend the machine's prediction with your own boots-on-the-ground intuition.
Which brings us to the ultimate golden rule of adopting time series analysis in your web workflow. Good analysis of the past, plus good mathematical forecasting of the future, plus your unique human business insight equals better decisions and ultimately much better results. It is simply an unbeatable combination.
We've covered a lot of ground today, from the anatomy of a traffic spike right down to the mechanics of an ARIMA model. But I want to leave you with one thought as you head back to your own dashboards. Don't just look at what happened yesterday as a static scorecard. Look at the patterns, find the signal and the noise, and ask yourself, what is your web traffic actively trying to tell you about the future? Thanks for joining me on this explainer, and hey, happy forecasting!